Simplifying problem 1, I will factor each expression. R squared plus RT has a greatest common factor of R. That's R times R plus T, which is divided by 2R. Division changes to multiply. We take the reciprocal of this, 16R squared up in the numerator combined with the previous numerator for multiplication, and R plus T now in the denominator. Canceling R, canceling R plus T, dividing by 2, that yields 8R squared as a simplified version of this problem. Number 2, factoring m squared minus 4, difference of squares, will factor into m minus 2 times m plus 2. Then that will be times 6m. I have 3m squared. I'm going to move that here and match it. Now 2 minus m converts to negative, or the opposite of m minus 2. Simplify by canceling. Factors m minus 2 cancel. 6 divided by 3, that will give us a 2. That m will cancel one of those m's. Carefully see what remains in the problem. M plus 2 times 2 in the numerator, and a negative in the denominator. This is acceptable. If you want to distribute the negative 2 to yield negative 2m minus 4, that can be done as well. Number 3. Division problem. Let's factor each expression. M squared plus m minus 6 will factor into two binomials. M plus 3 times m minus 2 divided by n squared minus 9, which is a difference of squares factoring into n minus 3 times n plus 3. And we'll be careful throughout this problem to not interchange m's and n's. Division converts to multiply, and we'll take the reciprocal, bringing n plus 3 to the numerator, m minus 2 to the denominator. And let's cancel common factors. It's none for m plus 3. M minus 2 will cancel m minus 2. N plus 3 will cancel n plus 3. Simplified result is m plus 3 in the numerator and n minus 3 in the denominator. Okay, that's the first 3 problems. Setting up the next set. Instructions are to simplify still. All right, problem 4. Have a complex fraction. You have a fraction in the numerator, fraction in the denominator. Fraction bar means divide. Let's factor everything. X squared plus 4x plus 3 factors into two binomials, x plus 3 times x plus 1. That's divided by a trinomial, which will attempt to factor into x minus 5 times x plus 3. And it's divided by this part here. Let's convert that to multiply and take the reciprocal, bringing x squared minus x minus 20 to the top and factoring that into x minus 5 times x plus 4. And the expression x squared minus 1 is the difference of squares, was x plus 1 times x minus 1. Okay. X plus 3 factor cancels x plus 3. X plus 1 factor cancels x plus 1. X minus 5 factor cancels x minus 5. So this simplifies to x plus 4 in the numerator and x minus 1 in the denominator. I looked that over briefly, and I'll move on to problem 5. Simplify. We have an addition problem, adding fractions, rational expressions. Denominators will need to be the same. So x plus 4 in the numerator. 6x plus 3 will factor into 3 times 2x plus 1. It's helpful to factor denominators to look for least common multiples so we can have common denominators. Plus 1 over 2x plus 1. All right, the second fraction is missing the factor 3 in the denominator. So multiply denominator by 3 to make the denominators the same. We need to multiply this expression by 3 over 3 so we don't change it. It's multiplying it by 1. That brings us to numerator of x plus 4 times, or plus 3, and denominator 3 times 2x plus 1. This simplifies to x plus 7 over 3 times 2x plus 1. You can distribute these and bring this to x plus 7. 6x plus 3. It depends on your teacher. It depends on what the multiple choice answers look like, or it depends on your convenience and comfort. Right. Number 6 is a subtraction problem. Subtracting fractions, denominators need to be the same again. So x minus x squared minus 1, factor that into x minus 1 times x plus 1. I'm going to subtract 3 is the numerator. 2x plus 2 factors into 2 times x plus 1. Let's find common denominators, looking at least common multiples. This denominator is missing the 2. We'll multiply numerator and denominator by 2. Now this denominator is missing the x minus 1. Multiply denominator and numerator by x minus 1. Common denominator is now 2 times x minus 1 times x plus 1. We have 2x here, 2 times x. We have 3x minus 3, all of which needs to be subtracted. So our simplified version will be negative x plus 3 over 2 times x minus 1 times x plus 1. You can bring the negative sign out, and that will be x minus 3. And 2 times x minus 1, x plus 1. And that completes problem 6. Okay, next set. This will have problems 7 and 8. Instructions are simplified. Number 7, addition and subtraction of fractions. 1 over y plus 2 over 7 minus 3 over 2. Y squared is y times y. Okay, this one's missing a y. This one's missing a y squared. Now the first one is missing the 2 and the 7. This one's missing the 2. And the last one's missing the 7. You have all denominators common. It's going to be 14y squared. Numerators simplify. 14y plus 4y squared minus 21. We'll rearrange in standard form. 4y squared plus 14y minus 21 for the numerator and 14y squared for the denominator. You could attempt to factor the numerator into 2 binomial factors, but that would not cancel anything with 14y squared. Number 8. Of a complex fraction. 2 plus 1 over x and 5 minus 1 divided by x. But this 2 needs to be multiplied by x over x, so we have common denominators there. And this 5 needs to be multiplied by x over x. So we have common denominators there. That brings us to 2. Bring this up. 2x plus 1 divided by x. And in the main denominator, we have 5x minus 1 divided by x. We can simplify this to 2x plus 1 divided by 5x minus 1 by canceling the common denominators there in the complex fraction. Okay, that's 1 through 8. Simplifying. Boom, boom. 9 and 10. Number 9. Identify the asymptotes, domain, and range. We have a graph and we have a function. Rational function f of x equals 6 over x plus 2 minus 5. We can get the horizontal asymptote. We see a shift down of 5. We'll have y equals negative 5. And we can get the vertical asymptote. Looking at the denominator, x plus 2 will be restricted at x plus 2 equals 0. So x equals negative 2 is the vertical asymptote. Now the domain, we can see otherwise all real numbers. except for x equals -2. We're going to go negative infinity to -2, parenthesis, union, -2 to positive infinity, parenthesis again because -2 is excluded. And the range, you can see the graph going up and down to infinity and negative infinity, except the horizontal asymptote is excluded. So we're going from negative infinity up to -5, and at -5 we continue on to infinity. All right, that looks good. Number 10. What is the equation for the vertical asymptote of the rational function? The rational function for 10 is f of x equals 1 over, and that's x plus 1, sorry, x squared plus 3x plus 2. Disregard what I said. What I have written is correct. All right, vertical asymptotes. We look for restrictions in the denominator, but let's factor to find our wholes. This factors into x plus 2 times x plus 1. X plus 1 will cancel out. That's a whole. So x plus 2 equals 0. Yields our vertical asymptote. X equals -2. And this was multiple choice. That was answer A. That completes 1 through 10. The next set, 11 through 16, the instructions are simply to graph each rational function. These will be sketch graphs. Let's rewrite this. F of x equals -8 over divided by x minus 9. Y-axis is f of x. There's the x-axis. Okay. Looking at x minus h plus k, we have 0, x equals 0 for our h, which is our vertical asymptote. The vertical asymptote will go through the y-axis. It's the vertical asymptote again. And k, the -9, will represent the horizontal asymptote. We have a vertical stretch of 8, and we have a reflection. So just sketching the graph, let's mark that -9 horizontal asymptote. I apologize. So we'll reflect it down. And we'll reflect it up. That will give you a sketch for this function, number 11. Right, number 12. Again, graphing. F of x equals 2 over x plus 4. X plus 4 in the denominator. gives us x equals -4 as a vertical asymptote. And the degree 1 in the denominator compared to a degree 0 in the numerator. Horizontal asymptote is 0. That will be y equals 0. That one's going through the x-axis. And we're going to have a factor of 2. Let's just bring it out a little bit away. First and third quadrants, we'll graph this, and that gives you a sketch. Number 13. Graphing the function f of x equals 3 over x minus 1 plus 8. Plus 8 identifies our horizontal asymptote y equals 8. And here we get our vertical asymptote x equals 1. So vertical asymptote at x equals 1. Horizontal asymptote at y equals 8. Going to be vertically stretched by a factor of 3. And if you want to pick a point this time, let's pick x equals 2. Plug in a 2. 2 minus 1 is 1. 3 divided by 1 is 3, plus 8 is 11. So 2, 11 would be our point. And then our graph goes towards x equals 1, and it comes down towards y equals 8. Picking the value 0 on the other side of the vertical asymptote. 0 minus 1 is -1. 3 divided by -1 is -3, plus 8 is 5. So you'd have 0, 5, which is down here. And your graph will go up towards the horizontal asymptote and down towards the vertical asymptote. That's a sketch. It's not going to touch the vertical asymptote. It never touches the vertical asymptote. Okay, that's 1 through 13. I'll divide this up into 2 parts. Thanks for watching.